Hey everybody. By now in the course, we've seen how a simple perceptron model can be used as a linear classifier. We saw it being able to classify zeros and ones according to logical rules. For example, an AND function, an OR function, and a NOT function. In that case, we had binary inputs, it was zeros and ones, and we wanted to predict an outcome variable that was itself also a 0 and a 1. I think our go-to example in class was whether a person was considered a catch for us or not. Over the next few minutes, I want to look a little bit more closely at the perceptron and try to isolate what places and things we can change in the model to kind of make it a little bit more general. Eventually, we'd like for it to do stuff like XOR, which we've mentioned before, but also some more complicated things as well, far beyond XOR. So let's see what we can do, what we can build with perceptron models. Our roadmap is basically going to fill in the spaces in this table. We're going to look at inputs, and our inputs were used to binary inputs when we did the logical rules. But we also did a couple of continuous inputs, or at least inputs that weren't 0 and 1. We saw that when we did the perceptron update rule. Some of our x values were -1. But really we'll see that those values can be anything. They just need to be fed into the model. It just needs a number. We're going to look at models that have one input, a one-dimensional input, two-dimensional input, three, and then even more generally from that. And then we'll do something very similar with the output variable. Up until now, we've only done perceptron models that try to predict whether someone is a catch or not, whether he's a 0 or a 1. And that's binary classification, right? There's only two options for a binary, 0, 1. But we may want to have something a little bit more general, like rather than picking whether you like one particular person, maybe you're looking at buying a car, and you're considering a dozen different cars. So you may want to try to pick one of a dozen. So rather than just having one binary outcome, you really are going to have like 12 binary outcomes. Maybe you'll pass on car 1, you'll buy car 2, and then you'll pass on cars 3 through 12. That would be a multi-class classification problem. And the perceptron can handle that pretty easily without too much by way of adjustment. A little bit, but nothing too crazy. And then rather than having a bunch of binary outputs, multi-class outputs, we could also have our perceptron model predict a continuous variable, a continuous number. Maybe we were trying to predict the sales price of something, or income, or height, or weight, something that takes on more than just a discrete number of different isolated values, but can be a whole range of values, a continuous number. Turns out that that's a really simple adjustment for us to make. So we're going to do all of that, and then we're going to end with slightly more complicated adjustments to the perceptron that will involve some more drastic changes in the structure. Essentially, we're going to go from what's called a simple perceptron to a multi-layer perceptron, which is also the beginning of what's been called deep learning. So we'll look to see how models that are kind of involved, that involve many different intermediate steps of computation, can be estimated and can be used by us to do prediction of either a binary or a continuous variable. So that's what's in store. Stick around.